What if the dinosaurs never actually died out? What if that massive asteroid that hit the Earth either missed or maybe it just wasn't quite enough to finish the job? Now, I'm not talking about some Jurassic Park scenario here. This is a serious thought experiment, and it's grounded in real science. We're going to explore an alternate 66 million year history of our planet.
Okay, so let's set the scene. The Chicxulub asteroid, it still slams into the Yucatan Peninsula. The Deccan Traps, these massive volcanoes in India, they still erupt, spewing gas into the atmosphere. But what if the ecological collapse just doesn't quite cross that final threshold? What if it wasn't a total mass extinction for the dinosaurs? So, what happens next? How does that one single change ripple through the next 66 million years?
And this is the key thing to remember. This isn't a world frozen in time, like a static Mesozoic era exhibit. No, this is a dynamic new Cenozoic era, just like our own. The big difference? Its fundamental rules, its entire ecological grammar are written by dinosaurs. The old dynasties are still running the show.
All right, so let's explore this new timeline. We're starting right after the Big Impact, in a world where the curtain on the age of dinosaurs, well, it simply never fell.
Here we see this huge fork in the road. In our timeline, the dinosaurs' extinction left this massive vacuum, which gave mammals like us their golden ticket. But in the Dino-Cenozoic, those jobs are already taken. The old dynasties, the sauropods, the hydrosaurs, the tyrannosaurs, they're all still there, enforcing the strict top-down discipline on the whole ecosystem. The laws of physics are the same, sure, but the biology rewrites the entire story. So with these absolute giants still roaming the Earth, how do they actually change the planet itself? Because they aren't just living on the landscape, they are actively engineering it, and on a planetary scale.
400 kilograms. That's about how much plant matter a single adult titanosaur needed to eat every single day. They were basically living engines, turning sunlight and plants into motion, and maybe most importantly, into manure. They acted as these massive walking conduits for transferring nutrients.
And this creates something we can call the sauropod effect. Think about it like this. A herd of titanosaurs eats its fill in, say, a floodplain. Then they migrate hundreds of miles away, following the new plant growth. And all along the way, they're depositing tons of nutrient-rich dung, basically fertilizing new areas. Their massive bodies trample down vegetation, creating gaps in the forest canopy that let sunlight reach the floor. Over thousands, millions of years, these simple routines carve out these huge biogeochemical corridors across entire continents. They're like elephants, yeah? But on a scale that's almost hard to comprehend.
But of course, where you have giant herbivores, you're going to have giant predators. And in this world, the apex theropods, the tyrannosaurs up north, the abelisaurids down south, they never give up their thrones. They are a constant, top-down pressure on the entire ecosystem.
This creates a totally different kind of world. In our Pleistocene, the lack of consistent apex predators allowed herbivore populations to just boom, which led to overgrazing and, funny enough, more fires. But in the Dino-Cenozoic, that just doesn't happen. The constant threat from theropods forces herbivore behavior to be vigilant, watchful. It's like a choreographed dance that shapes the entire landscape.
So we have this world shaped by these giants, but the planet itself doesn't just sit still. The climate clock keeps ticking. And millions of years of environmental change would force both dinosaurs and mammals to adapt in completely new ways.
And all the big climate shifts from our own history, they still happen. The planet bakes in a hothouse world, then plunges into a deep freeze as Antarctica ices over. Then grasslands start spreading across the continents, and eventually the rhythmic ice ages kick in. And every single one of these shifts is a massive evolutionary test.
And the dinosaurs, they absolutely rise to the challenge. Don't think of them as these static, unchanging monsters. As grasslands spread, we'd see the evolution of cursorial forms, basically dinosaurs built for running. To deal with all that abrasive grass, they develop high-crowned teeth, a trait we call hypsodonty, just like mammals did. In colder climates, their feathery, filamentous coverings would become more common for insulation. They are just as adaptable as any other kind of life out there.
Okay, but what about us? In a world patrolled by these terrifyingly efficient predators, how does our own primate lineage ever get a foothold, let alone develop something like human intelligence?
The key thing to understand is this. For an early primate, daily life would be incredibly dangerous. The forest floor, the edges of the woodlands, these places are being patrolled by fast, smart, visually oriented predators. Coming down from the safety of the trees is a life or death decision every single time, and that creates this incredibly intense pressure to get smarter.
This constant, high-stakes danger becomes the #1 driver for cognitive evolution. I love this quote. If predation is the mother of invention, then this world is an intelligence gymnasium. The only primates who survive are the ones who can outthink their predators.
So what do those solutions look like in practice? Well, first off, social bonds get way deeper. You get complex alarm calls, cooperative planning, real teamwork. And then comes technology. Fire becomes a shield against hunters in the night. And, this is critical, the invention of distance weapons, like throwing stones and later spears. That changes the game entirely. You no longer have to win a fight up close and personal.
This evolutionary pressure cooker eventually leads to things like agriculture and cities. But what would a human civilization even look like if it grew up in the shadow of giants? The answer would shape every single aspect of society, of technology, of culture.
A city in this world is, by pure necessity, a fortress. The very first proto-cities are basically just walled-in granaries. Architecture becomes an art of, quote, graceful fortification. You'd see things like elevated footbridges between buildings, massive ditches to deflect a herd of herbivores, and watchtowers with complex signaling systems using horns and drums. Every single part of city design is about managing the megafauna just on the other side of the wall.
And this has huge geopolitical consequences. I mean, traveling over land is just incredibly dangerous and expensive. So power, trade, communication, it all gets concentrated along waterways. Rivers and coastlines aren't just features on a map, they are the safe highways of civilization. They're the arteries of empire.
So after this incredible journey through an alternate timeline, what's the ultimate lesson here? What does imagining a world of dinosaurs actually tell us about our own world?
The real payoff, the big takeaway, is that this whole thought experiment gives us his amazing clarity about the deep connections, the ligaments, between life and the landscape. In the Dino-Cenozoic, you can literally see how a sauropod herd shapes a forest. You can feel how the presence of a tyrannosaur structures the behavior of every other animal from miles around.
And this really gets to the heart of it. A civilization that grows up seeing these massive ecological engineers every single day cannot so easily pretend that they're dispensable. Their impact is obvious. Conservation wouldn't be some afterthought. It would be a core part of how you run a country, a matter of pure, simple survival.
And that brings the lens right back around us. In our world, the great ecological engineers, the elephants, the bison, the wolves, they've been drastically reduced. Those connections they have to the landscape are now much harder for us to see, but they are no less vital. So the final question is this. If their world makes all those connections visible, what unseen ligaments in our own world are we being asked to see and to protect?